Hello and welcome back to another round of me going through the challenges in my book, The C Sharp Player's Guide. Just a couple of reminders from last time. I'm not doing a whole lot of editing in these videos. I'm trying to keep it very simple, partly so that I can actually get through all the challenges. If I have to do 6 hours of editing for every hour of recording, I'll probably never get through them all. So if I just keep it simple, that means I can get through them and get them in front of you. The other big reason for keeping this pretty unedited is I want you guys to be able to see the mistakes, the kind of the process and the journey rather than just the finished product. I do have, like I said last time, some advantages going for me. One is I know these challenges. I'm the one who wrote them in the first place, so I know what the author was thinking most of the time. And I've been doing this for a long time. So if your version ends up different than mine, don't worry about that at all. And again, I'm using 5th edition, but the 4th edition is extremely similar. I mean, it's for all practical purposes, it's identical here. So with that, let's just dive in. So we got through 6 challenges last time, and we're ready to try the 7th one. So we are to this one, the Thing Namer 3000. The goal is to recreate this program and then add comments to it to describe what's going on. There's a bug that we need to fix. We need to find and fix. And then there's a question to answer. Let me set that aside for the moment and open up Visual Studio. Last week I kept just using the same project. I'm probably going to do the same thing here too, but I am going to create a new project for this week. So again, this is the template I'm looking for, is this console app. If you filter it down to C# and console, it greatly limits what is in here. And you know this is the one you want because it does not say .NET Framework. .NET Framework is the old version. That's not the one you want. You want the one without that. And you can also tell because this says it works for Linux and Mac OS and Windows, as opposed to this one that doesn't say that. So this is the one I want. I will give it a name. I'm going to call this let's see. Let's call it week 2. We'll leave that location at the default. I'm going to keep this box checked to replace solution and project in the same directory. You don't need to do that. For a small project, that's my preference, as I talked about a week ago. And I'm just going to say next. I do want to make sure I get .NET 6 and not an earlier version. And create the project. In this case, all of this code is useless, so I'm going to delete it with one comment, and that is that we are in the level that discusses comments, and now we can see this for what it is. It's a comment. And one that I expect won't stay for too much longer in the templates. So I'm just going to delete all of that, and now it says the first thing is we need to rebuild this program. I could copy paste. I'm going to not do that. People who have a physical book don't have that luxury. But it doesn't take too long to write all this in. That last line is the trickiest. Let me double check and make sure I got that line right. The with a space plus B plus a space plus A plus of surrounded by spaces plus C plus a space plus D plus exclamation mark. Okay, I think I got it right. We could run this really quick just to see what happens. Make sure it compiles and it runs. How do you describe it? Squishy. The squishy hamburger of doom. That is the bug in the text displayed. So this is jumping ahead a couple of the bullet points, but maybe that's the first thing to fix since we're seeing it. I worried in making this challenge that especially if somebody is typing in like I did, that they might somehow like subconsciously fix it. If yours doesn't have that issue in there, then you're fine. But anyway, so we got two ofs in there. Of. The first question is like, where is the of coming from? Well, we have an of right here, and we have an of right here. And we stick this C on the end of this, so we will see of, and then coming out of C of again. We could fix this in a couple of ways. One of them is we could delete this right here. That'd fix it. We could also delete this here. I don't think there's any... I think either of those is fine. I think I'm going to pick this flavor, but again, there's not a particular reason for me to do that. Either one works, and if we run this again, now we'll see if we fixed it. The squishy hamburger of doom. So now it looks like it is. Looks good now. So we fixed that problem. That's the third bullet point. So what this is asking us to do is add a comment near each of the 4 variables that describe what they store. You must use at least one of each comment type. This is really just about getting practice with comments. I'm going to come in here and I'm going to say, so this is, I don't know. Again, like these, this is more an exercise in making some comments to try to add some value to the code. It isn't always like I don't know, like this particular code is not all that exciting, so the comments aren't going to be that great either, I think, no matter what. But anyway, this is the thing, the type of thing. Let's do that. And then down here by B, we can use the other comment type. I'll do /* and an adjective to describe the thing. Of course, I could stick this. Let's put this over here at the end of the line. A comment for this, what goes in here? A variable to hold all the doom. The version number. Again, these comments are not, like I said, they're not exactly thrilling, especially these last two where it's like these variables are holding a literal, like they're just very straightforward. It's hard to know what to say. If you struggled with coming up with some text to put in there, you are in good company because I am right there with you. But again, the point is make some comments. If you've done that, you're in good shape. And so I've done that and I'm there. Now let's answer that last question. Aside from comments, what else have we done to make your code more understandable? This is going to fly in the face of comments, but don't use comments if a variable name can do the same thing for you. And I think this is a good example of that. A, B, C, D, these are not fantastic names. There's the book, like we'll get to variables in the next chapter and we'll get through, we'll talk about that more too. But right now, like this variable name is not great, and that's a thing we could do. If we rename A to type of thing, of course we got to come down here and say type of thing. That's a very big improvement. Now I'm going to show you another little trick here. So there is a keyboard shortcut. Let's see if I can find it really quick. I don't usually. There it is. I don't usually use the menus to get to this, but it's this right here. So there's this refactor. A refactor is a change that affects the structure of the code. It changes the code without changing behavior. So renaming a variable to something better is that's a good example of a refactor. So there's several like refactoring tools that are in here, including the first one is rename, and its keyboard shortcut is Control R, Control R. So what I do is I just put my mouse on here, and you could put it down here too if you wanted. It doesn't matter where. And you just I've got my pinky finger on the control key, and then I use my pointer finger to hit R, and then you can see down here at the bottom, Control R was pressed, waiting for a second key of chord. I let go of the R, but I haven't, my pinky finger's still on R, and I just tap R again. And now it brings up rename. And if you look, you can see that it's this little box comes up. Actually, I can make this text a little bigger. This little box comes up, rename B. There's some options that I've got here, but usually the defaults are fine. And now I can start typing here. So B, remember we said this is an adjective or a description. So if I just type that in, you'll see that because I'm in this refactoring thing, it renamed it in both places. And if I had used this variable in 20 places, the same thing would happen there. Here I can hit apply, or I can just hit enter, and now it finishes the job. Let's rename these as well. Oh, I can't rename that 3000. Let's call it version. So now all of these variables are a lot more meaningful besides A, B, C, D, which are, like I said, not great variable names. In terms of what else could you do to make this code more understandable, for me, this line right here is the most complicated of them all. And there's some tools that we'll get to that I would normally use that I'm not going to do. But there's some things that I would do that I can't do right now. I'm not going to do because the book hasn't taught them yet. But what I will say is this Doom inversion, like I don't love how they're in there. Like I would rather just say of Doom 3000 right here in this case. And let me even do that. And then let's just delete these. They don't change. They're not variables. And so in my opinion, this code here is simpler, it's easier to understand, and so I think we just made this code quite a bit better by giving better variable names and also just by kind of condensing this. We don't need variables for things that don't vary. I'm sure there's a dozen other little things you could do here to help clarify stuff. For example, using some white space to kind of separate some of this. And perhaps if we do that, then maybe it makes sense to move the comment up and maybe give it something different, like get the type of thing from the user. Like I think that's a better better comment than what we had before, because an adjective to describe the thing doesn't add a whole lot beyond this description. I mean, it does a little bit, but not a whole lot. And then the comment we had here, was that always an adjective to describe the thing? We might have had no, okay, there it is, the type of thing. Like type of thing and type of thing. When the comment says the type of thing and the variable says type of thing, that has not added really any value in terms of comments, and we might as well not have it. But this comment here, I think it captures what the entire little chunk, the little block of code here is doing, and I think that's better. And I think we could do a similar thing here. Get a description of the thing from the user instead of this comment. I think that is I think these are better comments and better code overall. We'll probably spend enough time on this. Let's move on to the next challenge. But that is the thing namer 3000. All right, let's see. So the next challenge is a variables and knowledge check. The feedback I got last time was, yes, let's keep doing the knowledge checks in here. So at least for one more week, we're gonna do it again. Check your knowledge with the following questions. Name the 3 things all variables have. Every variable has a name and a type and a value. Some of them, so I mean, we see that right here. It's got a name, it's got a type, and it has a value that in this case is being stored in it. Of course, like we could do these on separate lines as shown in the chapter. In this case, we don't like it. It has a value. We just don't know what it is, and actually, the compiler will make sure we don't use it before we've put something meaningful in there. But so those are the 3 things, and you see them written out very explicitly in something like this: name, type, and the value that it currently contains. Of the 3, only the value it changes. The name can't change over time, and neither can its type. Variables must always be declared before being used. That's true. We can't, for example, so we must declare it before it's used. In this case, it's happening kind of at the same time. But what we can't do is do this and then come down here and say, oh yeah, well, somewhere in this method is going to be a variable called type of thing. In this case, we get a compiler error. Cannot use the local variable type of thing before it's declared. This must come before this for it to compile. Can you redeclare a variable? So declaring a variable, like that's what we do here. And the question is, can we redeclare a variable? Can we do something like that? The compiler does not let that happen. A local variable or function named type of thing is already defined in this scope. And it doesn't, like, even if we change its type, that does not matter. We are not able to declare a variable of the same name a second time. So the answer is no. Once we've declared a variable, it is like that is the one version of it in the entire method. Which of the following are legal C# variable names? So this one is legal. I think it'll be easier to point out the ones that aren't and say why. So this one isn't, because it starts with a number. You can't start a variable with a number. The compiler is going to assume you were trying to write a number here. And it might try and interpret that as a number and then try and interpret this as a variable value. But you can't start a variable with a number. You can, however, include numbers in it. So this one's okay. It starts with a letter, not a number, so it's fine. This one is not a valid variable name. A symbol like $, it can't ever be used as a part of a variable. Delete me, that this one isn't. There are plenty of languages where you can do a dash like that in names. C# is not one of them, and the reason for that is, as we'll see later, this is going to be interpreted as subtraction. So it's going to, like the compiler is going to say, it looks like you're trying to subtract me from delete. And so it's going to look around for a variable called delete and a variable called me, and it won't, that's not going to work. So this on the whole is not a valid variable name, though delete is, and so with me, but delete -me is not a valid variable name. Underscores, however, are allowed. So if you wanted to write it that way, that is a valid variable name. All capital letters, that one does count. You can use uppercase and lowercase, and it can contain numbers. It just can't start with a number. And underscores, you can also start a variable with an underscore. So that is that whole knowledge check kind of in detail. And let's go back to the start here and go on. So the next challenge is the variable shop. We're starting to get to some more interesting challenges now. All right, I'm gonna just delete this and start afresh. So build a program with a variable of all 14 types described in this level. I could go back and look, but I think I can do it from memory. So we've got int, and this doesn't give us this challenge doesn't give us any real meaning for these variables. We could normally I wouldn't use a variable name like this, but I'm just going to start lettering them. Int a, we've got short b and long c, and then we've got their unsigned counterparts. So u int d, u short e, u long f, and then we've got byte g and s byte, the signed version of byte. It's nice that it's giving me the answers here. So that's all of the types that are plain old integers, but we've got character. I'm going to say this because it's something that I noticed about myself a long time ago. There's a lot of people who, so this is meant to, conceptually it represents characters. There's a debate among programmers about how to pronounce this. It look like at face value, it looks like char. And there's a lot of programmers who will read this as char. And there are a lot of programmers who say, well, yes, but it's the beginning of character, and they'll pronounce this care. I think I mentally decided to avoid either, because I hate that it's char because it's a character, but I care when it's spelled C-H-A-R is weird to me. So for me, I always end up pronouncing this as character, even though it's only got literally half of those letters. It's not character, it's just C-H-A-R. So I always just mentally somehow pronounce that as character, which isn't true for the next one I'll do here, which is bool. And I pronounce that bool, not boolean. So anyway, just an RBism. I like it though. I once I recognized that I was doing it, I thought I'm gonna keep doing that, because calling this char seems weird to me and calling it care seems weird to me. So therefore, character it is. We got string, let's see. And now we got the floating point types. So float, it's suggesting a name here that wouldn't actually work because I've already declared it. I'm not going to use L. I'm not going to, 1 and L look so similar. I'm going to skip L and go to M, double N, and decimal. Even O is kind of questionable. O, especially a capital O, looks a whole lot like a 0. So I'm just going to skip that one as well. Let's see. Did we get them all? 14 types. 1, 2, yeah, we got 14 lines here. The next thing it says is assign a value to each of them using a literal of the correct type. I'm going to be kind of boring here. That is a literal of the correct type. The question here is it how do I make a short literal? And the answer is you can't. You make an int literal, and if what's going to be interesting here is every single one of these will technically work if I think even these, oops, got my spaces in the wrong spot. For the ones that are smaller, than an int, so this is an int literal. However, it's fine promoting to a longer value, and actually if you hover over this, you can see represents you can see it, although it's a little subtle. This says int 32, 32-bit signed integer. that is another way of saying this is like this int type is literally that as well. You can hover over this and it says a 16-bit signed integer, a 64-bit signed integer, a 32-bit unsigned integer. So you can see kind of what their description, and but if you come over here, you can see the type of the literal is a 32-bit signed integer. And there isn't a way to say, well, I want to make this a short literal. What you do is you just make it an int literal. And then if it's small enough, the compiler says, yes, that's fine. Like I mean, because this is 0, it says you're allowed to put that in here. For these longs, let's see. I'm going to put underscores in here to help. The book does talk about this, so I don't feel too bad about putting this in. These underscores, the computer completely ignores them. These are just so I can mentally like understand like where the separators are. So I've got 10 million here. That is not big enough. Let's get up to 10 billion. At this point, once I surpass what an int can store, now you can see this is just automatically started saying, well, this value is an int. Sorry, it's an int 64, which is a long literal value. So I can store it in here. If I really wanted to, I could put an L on here. That forces it to be a long literal, even if I remove a bunch of these. Like this is still going to be, it says a 64-bit signed integer. So that's a long, because longs are 64 bits. So even though it's small enough it could be an int literal, putting this L on here ensures that it isn't. That's not necessary here, but it does. Like if we want, like maybe that's, given how the problem is described, assign them each a value using a literal of the correct type. Perhaps this is a slightly more correct. Uint, same thing here. We can do this. We put a U on it that ensures this is an unsigned integer. Again, we don't have that option with these smaller values. There's no way to make a plain old U short literal. We must use an int literal that's small enough that it fits in, but the compiler checks that for us, so it's not a big deal. U long, again, we could do. Stick a U on there to make sure it's an unsigned type, and an L on there to make sure it's a long type. And so now this is a 64-bit unsigned integer, which matches that. And of course, this is a, like if we ever exceed the bounds, an S byte, a signed byte, can't get this big. It says, okay, your constant value of 255, it can't be converted to an S byte, because that's not within the range of an S byte. But because this is signed, I could do -10, and that will work. A character literal, you put single quotes. A bool literal will either be the keyword true or it'll be the keyword false, and either one would work. A string literal, we've seen these a bunch before. You put them in double quotes. I'm going to start with my double here first, because anything, so right here, this still is interpreting that as, you can see, a 32-bit signed integer, even though like it's able to convert an integer to a double. It's fine with that. If I put any decimal point in here, then it'll ensure that this is turned into a double. Now in this case, I need to do that, because otherwise it doesn't know how to. Otherwise it'll think I'm trying to access a member. So I do need to do that. I can do the same thing here for float, other than if I just do this. So again, like this now says a double precision floating point number. Here, this is a single precision floating point number. So this is saying like I can't convert that. And it even gives me the suggestion of how to fix it. Use an F suffix. So there, I put that F on there, and now it works. And now if you look at this, this value represents a single precision floating point number. So now this is the types match. Decimal, in order to do a literal decimal, I need to put an M on it. The M is for monetary. Decimal is primarily used for like financial calculations. Depending on the type of work you do, you may do that a ton, or you may do it hardly at all. And so that is the second bullet point, and then it says use console.writeline to display each of them. So I'm going to use my Control D shortcut here to just get a bunch of lines. Don't know if that's enough or not. It wasn't. Let's see, I got M, N, and P. So I got 3 more. M, N, and P. And I can tell I got them all now because although, like, if I don't have this, let me just comment this out really quick. If I don't have this, then the compiler says, you know, you got this variable, but you don't ever use it. You assign the value, but you don't ever read anything out of it. That seems wrong to me. It's suspicious, and so it gives you that compiler warning. So I know I've got them all because all my warnings have gone away up here. And at this point, I can run this to make sure it works. And you can see all the values that it printed out. And that's all this challenge is asking us to do. So let's move on to the next one, which is kind of a continuation of this. So the variable shop returns. Keep asking me how to modify the values of the variables they're buying. So modify this program to assign a new, different literal value to each of the 14 original ones. So, and then display them. So I'm gonna come down here and display them again. And then I'm going to copy this code and assign them new values. Now, in this case, I don't want to redeclare the variable, so I'm just going to update them, keep it simple. So I just I'm removing the type here because this counts as a variable declaration. This, now like this, is just a simple assignment. We're just updating the values. It does say assign different values to them. So we should probably change some of these. This is unsigned. I was going to put in a negative value, but this one's unsigned, so we better keep it positive. I don't remember what E was. Maybe I should have had better variable names. This is a U short, so and G is a byte. True is the only other choice for Booleans that are either true or false. There, updated values and then displayed again. And now we can see, I could have put a blank line in here. That might have helped separate these. So I could have just done, you know, a console.writeLine and something and just gotten a blank line. But so the first set comes down to here, and then the second set is these, and you can see that all these values are now changed. And I think that completes that challenge now too. So let's see, where are we? We are at this knowledge check about the type system. Check your knowledge with the following questions. True or false, the int type can store any possible integer. It's meant to store integers based on its name, but it can't store any possible integer. It has a range. There's a minimum value and a maximum value, and if you go beyond those, it won't work. That range is about -2 billion to +2 billion. So if you want to store a number like 1 quintillion, you're out of luck with an int. 2, order the following by how large their range is from smallest to largest. So a byte is 1 byte in size. It stores numbers 0 to 255. A short has 2 bytes, and it's like -32,000 to +32,000. So that one's the smallest. This one's the next, and basically it's just the number of bytes. So this is 4 bytes, and this is 8 bytes. And at least these three, I hope, are very intuitive. In just kind of the middle ground. Short is smaller, long is bigger. So short, int, long. But then, like I said, this is 8, 4, and 2 bytes. So byte is 1 byte, so it's even smaller. So that's the order: is byte, short, int, long. Let's see. From smallest to largest. Is that, yeah. True or false? The byte type is signed. Int is signed because it has a sign. It can be positive or negative, short, long. But byte is not. Byte is 0 to 255. Everything is presumed positive. If you want a signed byte, then you use the S byte type. Number 4. What can store higher numbers, int or uint? They both have the same number of bytes, but because int must be able to store basically as many negative values as positive values, it can't go quite as high as uint. Uint is able to go twice as high up because it doesn't have any negative values. So uint is able to store higher numbers. Int is able to store lower numbers. So they can represent the same total number of values, but they're shifted from each other. 5. What 3 types can store floating point numbers? Those are the ones that were described in the floating point number section. Float, double, which is double precision, and decimal. 6. Which of the options in question 5 can hold the largest numbers? So of those floating point types, the one that can get the biggest is a double. It stores just absolutely massive, gigantic numbers. Number 7, which of the options in question number 5 is the most precise? So this is the reason why decimal existed, is for financial calculations. You don't need the same range. The size that float and double can get to is kind of crazy. But with a financial calculation, being precise, like not being off by as much, is way more important. So that's the reason why decimal was created, and so the answer to this one is decimal. What type does the literal value 8, including the quotes, have? Because of the quotes, this will be a string. If the quotes weren't there, it would be an int literal. And if you put single quotes around it, it could be a character literal. What type stores true or false values? That is the purpose of the bool type. It's meant to store logical values or truthiness values. Is something true or false? That is all of those. So let's jump up and do. I'm kind of over time, but I spent a lot of time on the thing namer, and I want to get to at least one more. So let's do one more. So the triangle farmer. Let's see. Is that always off? So this is asking us to basically make a program where we can enter a triangle's. Let me skip this back over. Basically, we need to be able to enter the base and the height and compute the area from that and display that. So this is the first challenge that I think has like a lot of flexibility. Like people are going to do some fairly different things here. I'm going to try and keep this fairly simple though. So the first thing we need to do is get the base size. So I always start with some sort of prompt. I used base here, but length would also be a pretty good name for this. And then I'm going to, so I'm going to, let me keep this simple for a second. So string, I'm just going to say length text equals console.readline. And then I'm going to convert it. So, and it's suggesting something, I'm okay with that. Fifth edition does call out this float.parse. Fourth edition only really, at this part of the book, only really talks about console.convert. Sorry, it's not console. It's just convert dot to int. Sorry, to single. So this takes the tells the user what it's looking for, waits for them to type that in, and then converts it to the right type. This right here I could have used decimal, or I could have used double. Float seemed precise enough for what we're doing here, but in fact, I don't think it would be wrong for this to have necessarily, it's a little bit limiting to limit ourselves to just int here, which is why I chose float. But if you chose int, that's not wrong, I don't think. Now I do want to, so given this, I see a lot of people write it this way. I have a tendency to compact this a little more. So rather than take the returned value from console.readline and storing it in a variable, I'm just going to make and then down here, pulling the value back immediately after that out of the variable to pass to convert.toSingle. I'm just going to make it, it is a more complicated expression because it's kind of doing two things. It asks console.readline to get a value, and then it feeds that into convert.toSingle. But in my mind, that simplifies the code. I have one fewer variable, and for me, this version of the code is pretty easy to read. If it's not easy to read for you, then by all means, do it the other way. Have a separate variable. So, and then now I gotta also get the height. So I'm gonna actually steal this. What is the height? And I'm gonna make float height. So different variable, different name. So now I've got two variables, length and height, that both are given to us by the user. And then compute the area of a triangle by turning the above equation into code. So this part can be a little tricky. I gotta take that equation, base times height divided by 2. I gotta somehow write it as code. Now, I happen to, I'm just noticing this, I happen to call this length, even though the equation says base. Like I said, either one would theoretically work. Turns out base is a keyword, so I actually, that's a reason to use length. You know, as I'm thinking about this, it makes me wonder if I shouldn't change the challenge in the future just to avoid that kind of thing, so somebody doesn't try to call this base. Anyway, let's see. So I need to do the length times the height divided by 2, and I could do length times height divided by 2. There's a catch. This. No, that's okay. I was going to say this is it does them in the wrong order, but it's all multiplicative, multiplication, division. We're okay. Okay, we're fine. Everything's fine. And now the last step is to write this out. Let's give this a go. What is the length of the base of the triangle? Let's do something that we can double check. So if I have a triangle whose base is 1 and height is 1, and then we get the area of that, it should be 1 times 1 divided by 2, which is a half, 0.5. So if I just do 1, 0.5, that looks right. Let's do one more just for good measure. What is the length? So let's say we have something that is 4 long and 2 high. That would be 8 divided by 2 is 4. So I expect this to display 4. There it is. Okay, so I think that is a version of this code that does the job. I'm kind of itching to keep going. Let's do one more. we are to the Four Sisters and the Duckbear. So Four Sisters own a chocolate farm and collect chocolate eggs laid by chocolate chickens every day. They divide the eggs, but they always fight over who gets the uneven amounts. So the plan is this: their pet Duckbear gets the remainder. So we got to somehow compute how many eggs, like, given a number, how many eggs does each sister get of the Four Sisters, and how many does the Duckbear get? So create a program that lets the user enter the number of chocolate eggs. Actually, I'm going to undo this here because this code here is very close to what we're looking for. So how many eggs were there today? And I'm going to use an int here, to int 32. Because eggs there shouldn't be fractional eggs being laid. And if there's somehow a broken egg, that probably gets discarded. But who discards chocolate, right? Okay, create a program that lets the user enter the number of chocolate eggs gathered that day. Okay, we've checked that off. Using slash and percent, or slash and divide and remainder operators, compute how many eggs each sister should get and how many are left over. All right, so int eggs for each sister equals length divided by the number of sisters. Int eggs for Duckbear. Is it one word or two? One word. Duck equals length, that remainder operator for. Now, yeah, so with integer division, let's suppose I enter in 5. If I do integer division, 5 divided by 4, I get 1, and everything, like, so like normal math-based division, floating point division, if we do 5 divided by 4, we would get 1.25. Because we're dealing with integers here, and we're using integer division, this will give us the whole number and discard any fractional value. So this actually should get us, if we do 5 divided by 4, this should get us the whole value, which is 1, and any fractional value beyond that just disappears. So should give us the right answer in terms of the number for each sister. So if there's 5, each of them gets 1. And then there should be 1 left over, which is what this thing should compute for us, is this gets us 5 remainder operator 4, which a lot of people call that mod, 5 mod 4. Technically, there's some differences between mod and remainder operators, and C# is a remainder operator, not a mod operator, and for positive numbers, they're identical. For negative numbers, it changes things. But so this code right here, I think, should do it. And now we just need to display the output. Console.write line. Each sister gets, oops, not for Duckbear. Now we run this. How many eggs did they say? The example I was using was 5, so let's just run that. Each sister gets 1 chocolate eggs. The Duckbear gets 1 chocolate eggs. The fact that it says 1 eggs bothers me. We don't have the tools quite yet to, like, say, well, if it's 1, then do this, and if it's not 1, then, you know, if it's 1, use a singular form, and if it's more than 1, use a plural form. The poor man's shortcut here is this. I kind of hate that too, because it's like, I don't know, eggs, maybe, yes? And that always bothers me too. So, I don't know. So we don't have the tools to handle that pluralization all that well. I'm okay leaving it like this. And, I mean, another thing you could do is eggs for each sister, colon. Instead of writing it as a sentence. Now it doesn't matter. Like eggs for each sister, 1. It reads totally fine. So that's another way to get around that. All right. Let's see. There's a question to answer here, and that is, what are 3 total egg counts where the duck bear gets more than each sister does? You can use your program to help you find an answer. If we just pick a number, 12. Eggs for each sister, 3. Eggs for the duck bear, 0. So this is one where the duck bear, this one doesn't count. Each sister got 3, duck bear got nothing. We run that again. So we could just pick some numbers. 1,000. Each sister gets 250 eggs and the duck bear gets nothing. So we could just pick numbers and try to find them. I do think that if we use a little bit of intuition and think about obviously in order for the duck bear to have more than the sisters, the more eggs there are, if we have 1,000, sisters are each going to get a lot, no matter what the number is, because the remainder is only there. If we ever have 4 left over, we don't have 4 left over. Each of the sisters get 1. So the duck bear will never end up with more than 3. So we want to keep the number of eggs the sisters get small. So we just start small. If we put in 0, nobody gets anything. If we try 1, hey, look, the duck bear got 1, and each of the sisters get nothing. So that one counts in terms of answering that question. 3 total egg counts where the duck bear gets more. I think probably you guys can probably intuit it from here. Here's another one. If we do 2, the duck bear gets both of those. The sisters get none. If we do 3, so there we found for 1, 2, and 3, the duck bear gets stuff and the sisters don't. But I mean, if we do say 6, that's another one. The duck bear gets 2 and each of the sisters gets 1. So I think that answers that question. We're getting close now at this point to an hour. So I think, and I meant to do this only for a half hour, so I'm going to stop at this point. Let's see. So we covered, let's kind of summarize this really quick. We started here with the thing namer. Where we were adding comments in, did a little bit of code cleanup. This knowledge check about variables, asking a bunch of questions about the nature of variables. And then these 2 were kind of a pair where we just made 1 variable of every single type, assigned them values, displayed them all using console.writeLine, updated them, the returns, we updated them all and displayed them again. This one had a bunch of, honestly, a little bit tricky questions about which types are useful for which things. The triangle farmer, we finally got to a point where we were doing some actual real work. That's our first real meaty program that does something really useful, I think. Some math that not everybody is going to be able to just do. So we solved a problem for the triangle farmer who was trying to do this all by hand and simplified his life. It was a pretty straightforward, just simple math equation. The force systems of Duckbear uses some more, that one is a bit more complicated. That remainder operator isn't used that often, but it definitely has its uses. So this one was a slightly more challenging thing, even though the experience points is the same. So yeah, I think that summarizes what we did today. I hope to do this again in the relatively near future. I did it last Saturday and this Saturday. Maybe it'll be next Saturday. That's a guess, not a promise, though. But so now let's see. Where are we at? So we got 100, 200, 300, 400, 500, 600, 700, 800. We have 800 experience points at this point. And so that is 100, 200, 3, 4, 5, 6, 7, 8. So we have made it to level 3, and we're actually a third of the way to level 4. We're making good progress. I think that's it for today. So we'll wrap things up here, and I will see you soon.